Hello. Whether we're Banksy, or a graffiti artist, or a tagger, we all like to doodle. So we started thinking if we could scroll on a computer monitor using a mouse, touchpad, or touchscreen. We wondered if it's possible to use our phone's gyroscope to doodle on a computer. We set out trying to create a solution to virtual art with no extra hardware, and it was quite difficult. I'm Elliot.
I'm Liam.
I'm Luke. And I'm Boyte.
And we would like to introduce Smart Scrawl.
Smart Scrawl is a fun way to create virtual doodles using your smartphone as a pen tool. The wireless connection to a fast server allows for quick upload of coordinates on a canvas. Connection to social media and to the Google Maps API brings doodle mapping and sharing as easy as ever. We are going to attempt a live demo for you, depending on the internet.
So this is the canvas on our website, and we have a willing volunteer in the audience, Jim. So if you would like to use the app to select a colour and select a brush.
Jim looks like he's been wounded in action.
He has. He actually has to use
Is
his
this
left
from
hand on this
Smart
one.
Scrawl? Oh, a skateboarding injury, okay.
There we go. So we're streaming the data live from the phone, and we're drawing on the website.
Cool.
I must say that Jim's artistic skills are heavily hindered due to the left hand.
Should we try and say it?
You go for it, try.
Yeah.
It's like
So
Banksy's in
we
the
shall
room.
attempt to save it.
Go. Don't understand.
Whatever that is.
So after saving your canvas and you log in with social media, you can view where you've drawn something on a map. I don't really know what that is. I don't think Jim knows either.
So the way it works is that we get your accelerometer and compass data from your phone, which is in the form of raw, yaw, and pitch. But then the difference is your phone's axis is different from the real-world axis. So we need to use some method to convert the phone's axis to the real-world axis. So we get the raw, yaw, and pitch, and we times it by a rotational matrix, which is a transformation from the phone's axis to the real-world axis. So then that'll give us new raw, yaw, and pitch values that we can use in our application. But the problem is that there's noise in the values from the phone, so we need to pass it through a filter. And the filter that we chose is called a low-pass filter. And this is what the equation looks like in the code. So what it does is it turns the raw readings to a smooth reading, depending on what phone you've got. So our phone is probably good, but if you've got a better phone, you would get a smooth curve like that. So then after we've filtered out the raw, yaw, and pitch, we send it to our Firebase database, which is where all the information gets processed.
So, as we said, it gets the information from the phone systems and it's sent to Firebase. Then the dedicated server gets that data and translates the gyroscope information to coordinates on your screen, which is then sent to the web page where it's drawn on a HTML5 canvas using JavaScript. All this happens in real time as you're moving around your phone.
So the website features a personalised profile for each user, which lets you save, retrieve, and edit your drawings, meaning you can view them, you can change them however you want, and they'll still be saved, and they're available to view. And then we also have the Google Maps integration, meaning other people can see your drawing and you can see others.
And also one thing is that we convert the canvas to a picture, then we save the picture as base 64 in our database, which means we don't have to get a separate image server. So it's just saved as a text file in the database, and we just convert it back the other way around.
So in the future, we hope to actually integrate this with the Microsoft HoloLens or the Google Glass, and you could walk around with virtual reality of all the artists' work that they've made. It could be 3D. This is a video demonstration of what it might be like. You could have 3D graphics animated, maybe even interact with the graphics. And the best thing is, you can turn it off, whereas in real life, you can't choose not to see graffiti. Thank you very much.
Well done, Smart Scrawl. Wow, that was 5 minutes on the button. Questions?
Yeah. So how does your web app communicate with Node?
We'll let Liam answer this.
Yeah. So all the information is sent into Firebase, and then what we do is on the Node server, we use that and get the Firebase information. So we just retrieve it, and any time that data changes, it calls an event, and then we just change everything accordingly by using all the JavaScript. So that's how it communicates.
And also from, when the guy was demonstrating the app itself just then, so he uses matrix transformations on the fly.
Yeah.
Does that get over Wi-Fi? Or because I saw there was quite a few latency issues. Have you looked into other technologies such as Bluetooth or any other wireless technologies?
Well, we're trying to use a website, so we can't really communicate.
Oh, so does that
Bluetooth.
post directly to the website? Or
Yeah.
Okay, right.
Yeah.
Okay, thanks.
Finished? Cool, thank you.
Is that everyone? Okay. Well done, Smart Scrawl. Thank you very much indeed.